Okay, so here we want to figure out what is the value. So that means the numerical value, right? When they ask for the value, that means they want a number. Sometimes you can solve an equation, you don't get a number, you get it in terms of some variable. You add like an x or a y or something in your solution. Here, when they say the value, this is a sort of indicator word. That means we want a number out of this. And what number do we want? Well, we want the number that negative 3 times x squared times y cubed is going to be when x is equal to 2 and y is equal to 4. So all this means is we're going to take x, or we're going to take 2, and plug it in for x here, so square it. And we're going to take the y, or the 4 here, and plug that in for y and cube it. And then we're going to multiply those two numbers together and multiply them by negative 3. And that's going to be our answer. So our answer is negative 3 times 2 squared times 4 cubed. So again, to keep with our color coding, this is my x is 2 and y is 4 cubed, or y is 4, so we have a 4 cubed here, and then I have this negative 3 hanging out at the front. And so this is going to be negative 3 times, and by the way, I didn't write the multiplication sign here, but when we leave this out, right, this just means multiplication. If I write x times y, or I write x, y, that means x times y, right? 3x means 3 times x. So, but here I'll write the multiplication sign to make it really explicit. But if you see something with a dot, right, 3 dot x, or x dot y, or more commonly just 3 times x, right? Y x squared, that means y times x squared. So this is going to be 3 times, well, 2 squared is 2 times 2, which is 4. What about 4 cubed? We'll do this one in stages. This is 4 times 4 times 4. Hopefully we know that 4 times 4 is 16. If I want to multiply 16 by 4, I take 4 and multiply it by, actually let's break this down even more. This is 4 times 10 plus 6. So I distribute the 4 in. I get 4 times 10 is 40. 4 times 6 is 24. So this is going to be 64. So here I have negative 3 times 4 times 64. And then I'm going to multiply these out. I'm going to multiply these together. And how do I do this? Well, we'll just do it one at a time. Right, I'll get 64 times 4. Let me do it again the same way. Left to right here. I'll have 4 times, maybe a nicer times symbol, 4 times 64. This is 4 times 60 plus 4. But how do I do 4 times 60? Well, I know that 4 times 6 is 24, right? And then I just add a 0 at the end. This is 6 times 10. So multiplying by 10, you just add a 0 at the end. So this is going to be 240, right? If I can multiply any two one-digit numbers, I can multiply by two-digit numbers, right? I can just break it up like this. And then whenever there is a multiple of 10, you add a 0. Whenever there's a multiple of 100, you add 2 zeros. That's it. So this is going to be 240, and so that's the 4 times 60. 4 times 4, we know, is 16. So this is going to be 256. And then I go back and I say, okay, what is 256 times negative 3? Well, same exact thing. I have negative 3 times 200 plus 50 plus 6. I know that a negative times a positive is negative, so I'm just gonna leave the negative out here and do my multiplying the 3 by the 200 and so let's do this one step at a time. This is going to be negative, in brackets I'll have 3 times 200 plus 50 plus 6, and then I'm going to distribute in that 3. Same thing, I'm going to get negative 3 times 200 plus 3 times 50 plus 3 times 6. And again, this is just the same thing as doing single-digit multiplication. 3 times 2 is 6, and there's 2 zeros after it. So this is going to be 600. 3 times 5 is 15, and there's a 0 after the 5 multiplied by 10, so plus, so I add a 0 here, this is 150, and then 3 times 6 is 18. And so this becomes, should have been an equal sign here, this is equal to that, which is equal to that, which is equal. Well, what's 600 plus 50 plus 18, or sorry, 600 plus 150 plus 18, well, 600, 150, 18, I can add it like this, right? 0 plus 0 plus 8 in the ones column is 8, 0 plus 5 plus 1 is 6, 6 plus 1 is 7. This is going to be, with the negative sign that we carry down, because it was, this whole thing was being multiplied by a negative 1, right? I just factored out the negative 1 from the 3 here. Negative 3 is 3 times negative 1. This is going to be negative 768. And so that's it. Right, no need to do all this big multiplication at once. Right, break things down into smaller steps, into little pieces. So we only ever have to multiply 2 single-digit numbers. So if I know what all my single-digit numbers multiply to, then I can just break things up and keep track of how many zeros I have. Right, if 2 zeros after the number, then you multiply the single digits and then put 2 zeros, and then I can just add them all back up again. And this is the key to making the sort of bigger math problems seem smaller. This is math in a nutshell, right? We take problems which seem big and complicated, break them up into smaller, simple pieces, and then put them back together again. And that's it.